In the previous video we saw this theorem. The intersection of any number of subspaces of a vector space V is a subspace of V. We even took the proof for this, okay? So the intersection, have here the intersection of subspaces is a subspace too. Now in this video we are going to see if the union is also a subspace. So our question in this video is if W1 and W2 are subspaces of a vector space, is that true that the union of two subspaces is always a subspace of a vector space? Okay, let us say we have V and we are here in R2 and we pick W1 has A0 where A is a scalar in the reals. Okay, and we are going to pick W2 and that will be 0 and B such that B is in the reals. Okay, so if you look well, at the end of the day W1 is the x-axis, right, in R2, and W2 is the y-axis. Okay, basically that's what those two are. So easy to check that W1 is a subspace of V, and easy to check that W2 is a subspace of V. Okay, you can use this corollary we saw in the previous video. If W is a subspace of V, or W is a subspace of V if and only if 0 is in W or 0 is non-empty, and picking two vectors in the subset, if AV plus BW, meaning if we multiply these two vectors by two scalars, this addition is also in W, then we say that W is a subspace, okay, for A and B scalars in the field. So it's just a vector field, okay, and this is the scalars where you get the field where you get the scalars. Okay, so using that, it's easy to check that W1 and W2 are subspaces of the vector space here. Now let us pick a vector U. Let us say here a vector that will be here 1, 0 for instance, and let us pick a vector V. Let us say 0, 1. So it is here in W2, right? Okay, so U plus V, they are both, one is a vector from W1, the other is vectors from W2. So this vector will be in the union W1, W2. Right? Well, yes, it will be in the union. But U plus V is 1, 0 plus 0, 1. That means that is 1, 1. Okay? But 1, 1 does not belong to W1 union W2. So W1 union W2 is not a subspace of vector space V. So we saw in the previous video that the intersection of any family of subspaces is a subspace, but here we see that the union, in general, the union of two subspaces might not be, in general, is not a subspace. So sometimes you might get a union where you get a subspace, but in general you don't. Okay, we can find two subspaces like this one, W1 and W2, to get the union, and the union is not a subspace of a vector space.